moving on to our second theorem. This theorem is the side, side, side theorem. So this is our SSS theorem that we do, and we love that one when we're talking about congruent triangles. But we're going to look at this side, side, side similarity theorem, which means that if corresponding sides of two triangles are proportional, going back to the stuff we learned last week, then the two triangles are similar. So we're going to decide whether the triangles are similar, not similar, cannot be determined. We must always, again as a reminder, go smallest to smallest number, medium to medium, and largest to largest. So looking at one, we have AB being 4, AC being 2, BC being 6, DE being 2, DF being 1, and EF being 3. So what we have to do is the exact same thing we did to determine scale factor ratios and if two similar polygons are similar. We have to go from one side to the other. So we're going to go smallest to smallest. So the smallest number between 2, 4, and 6 is 2. So we're going to see that it is 2. And we now need to go to DEF and find the smallest number, which is 1. So we determine that 2 over 1 is 1 ratio. And we see that simplified, it is 2. We are now going to move on to medium to medium. So we've already used 2 and 1. Now I'm going to look at the next smallest number, which is 4 on ABC. Now that we've looked at 4, we're going to go to our next smallest number between 2 and 3 and see it is 2. So we're going to see 4 divided by 2, which is the exact same thing as 2. That's looking pretty good. So now we have to do the largest. And we see 6 and 3 is what's left over. So we go 6 over 3 and we see that the answer is also 2. Well, sweet. 2, 2, and 2. Again, what it says is when all proportional ratios are the same, you have a scale factor of 2, and they're all similar. So these two are similar due to the side, side, side similarity theorem. Okay. You feel confident enough to move on to 2? You're doing the exact same thing. Make sure you go smallest to smallest, medium to medium, and largest to largest. Okay, so I'm going to put on number 2, small, medium, and large next to the numbers. So 6 was the smallest, medium was 9, and the largest was 12. I'm going to do it again over here on the second one. 6 was the smallest, 10 was the middle, and 14 was the largest. So now I just need to put them into proportions. So I'm going to go small to small, which is 6 over 6, and we're going to see that simplifies down to 1. Medium to medium, I have 9 over 10. That can't be simplified, so that's looking interesting. Those are already different. And then we're going to go large to large, where we have 12 over 14. When we simplify it, they're both even, so we're going to divide by 2 and see that this is 6 over 7. Our 1, 9 over 10, and 6/7 the same? Nope, they are not. So therefore, there is no scale factor, and they are not proportional. Therefore, it is not similar. Okay? So make sure you check all 3. Even though we already went past 2 and noticed those aren't the same, it's still a good reminder to do all 3. So, if you could, I would like you to go on to the next one and see if you can determine. You can do this one by yourself. You are looking again at number 1 that says, can you find similarity between number 1, A, B, and C? Yeah, I know, I'm sorry. B and C got erased. But A, B, and C. So we can see that this is 4, 6, and 8. Okay. So we need to find and determine if A, B, or C are the exact same thing. Well, first off, we already have fractions. Whoa, number A, letter A. I don't like fractions. And the nice thing is, though, they both have the same denominator. Since they have the same denominator, I'm actually going to get rid of it by multiplying by the denominator. So I'm going to multiply A by 3 because the 2 numbers on the bottom are 3. So when I multiply by 3, 2 times 3 becomes 6. 8 over 3, the 3's cancel, so this becomes 8. 4 over 3, the 3's cancel, and this becomes 4. So I have 6, 4, and 8. Do I also have 6, 4, and 8 over here? I do. Therefore, I have determined that 8 is also similar to 1. Okay. Looking at B. Well, we have a bunch of odd numbers and we're trying to have even numbers, so maybe, well, we have 3, 5, and 7. Let's look at factors. I can't divide them by anything that's the same. I can multiply, but is there any way I can multiply 7 to get to 8? Because those are the large numbers. I don't think I can multiply 7 to get to 8. So there is actually nothing we can do to say that this triangle is similar to that one. Now we're going to move on to C. We can see that we have 4, 3, and 2. This is starting to look a little bit better. But 4, 3, and 2, they maybe can do stuff. I can't divide anything because 4, 3, and 2, they don't have a similar factor. Well, how can I get 2 to maybe be 4, 3 to be 6, and 4 to be 8? Well, I can multiply by 2. Let's see if I can multiply by 2. So when I multiply by 2, 4 times 2 is 8, 3 times 2 is 6, and 2 times 2 is 4. And does 8, 6, and 4 match that 8, 6, and 4? Yes, it does. So therefore, C is also a similar triangle. Sweet. So you have just learned side, side, side similarity theorem. I think you guys will get that one down fairly quickly. I'm hoping. So it's just a review of 7-2, and then making sure we can get through it. Our last similarity theorem today is the side angle side. So we need to have a side that's proportional, then an angle, and then another side. Make sure it is then that order or else it does not work. Okay. So we have examples. Sorry, one second. Moving on to theorem. If an angle of one triangle is congruent to an angle of a second triangle and the lengths of the side that includes those angles are proportional, then the triangles are similar. So we can see through number 1 real quick. Let's see if this works. We have a side length of 5 and 10, and then the second triangle of 10 and 20, and it says these two angles are similar to each other. Okay, well, we have an angle in between two sides. It's already a good side, but we have to determine if the ratios are proportional to each other. Well, 5 is the smallest and 10 is the smallest to the respective triangles. So we're going to take 5 over 10, and we should try and see if we can simplify it. 5 and 10 both have a 5, so we divide by 5 and see it's 1/2. Okay, so that's a good start. Well, our next side is 10 and 20. So we're going to look at 10 over 20, and when you divide by 10, you're going to also get a 1/2. These are similar, so we're proportional to the two sides. And because we have an angle, it's side, angle, side. These guys are similar to each other. That's awesome. Okay. Moving on to 2. 2 has 4, an angle of 35 and 8, and another triangle that has 6, angle of 35 and 9. Well, the angles are the same. Sweet. That's a good start. We now need to look at sides. So looking at our sides, the smallest number over here is 4, and the smallest number between 6 and 9 is 6. So we can see 4 over 6. We're going to simplify it. They're both even, so we're going to divide by 2 and see that this is 2 over 3. We now need to check our next one. This side length's next number is 8, and our other one is 9. Is there any way we can simplify 8 and 9 to each other? Well, 8 is 2 and 4, and 9 is 3, 1, and 9. So no. So we have two ratios of 2/3 and 8/9. They're not the same. Therefore, these are not similar. Okay, we have to determine. So putting this knowledge again down to use, we're gonna look at a triangle that has a side angle and a side, and we need to determine if A, B, and C match the original triangle. So we can see here we have 6 triangle with a 90 degrees and an 8. Well, let's just look at A, B, and C. They do all have a 90-degree triangle, so that's a good start. That means they are similar to each other. But first, we have to determine, well, can we make them similar to each other? Yeah, see what we can do. So again, if you can't see that, you should maybe look for similarities in factors. You can always go back to this method. So I'm going to take the smallest 6 over the smallest. I'm going to tell you that 20 over 3 is 6 point, oh shoot, 6 point, I think it's 6.7-ish. So we can see 5 is the smallest one over here between 20 over 3. And we got 6 over 5. Well, I can't simplify that one. So I'm going to see if I can do the same thing, but with 8. So we have 8, and it has to correspond to 20 over 3. This goes back to the multiplication of fractions. We can see 8 divided by 20 over 3. This is the exact same thing as saying 8 times 3 over 20, okay? We have to remember that if there's a fraction in the denominator, we can multiply by its reciprocal where we flipped it. So this is going to be the same thing as 24 over 20, because 8 times 3. And we can simplify 24 over 20. I can take out a 4 from both of them. If not, you can divide by 2 because it's even, and then see if you can simplify it any more. So this actually becomes 6 over 5. Well, hey, that matches. Even though it took us a while to get there, the 2 ratios match. We have an angle. So A works. That's always good to see. So we're going to look at B. Again, if you struggle to see factors that could either multiply to get this one to that one or divide or vice versa, please make sure you're doing your proportional ratios. So looking at B, we have 3 and 4. Are 3 and 4 potentially very similar to 6 and 8? Yes, because if you multiply by 2, you're going to get 6 and 8, and we can see B is also a similar triangle. So now we need to look at C. Well, 6 and 4. Well, if I divide by 2, I get 3 and 2. If I multiply by 2, I get 12 and 8. It's not really getting us anywhere though, so we can check. So I'm going to take the smallest, which is 6, and the smallest over here, which is 4. And see, this is the same thing as 3 halves. Now I'm going to take the largest 8, and the next largest over here, which is 6. And this is the exact same thing as dividing by 2, 4/3. Well, 3 halves and 4/3 really don't work, so C does not work. Let's go ahead and take a break. You have just learned the last 2 theorems, then we're going to put it all together.